Ever pondered about the birth of our universe and how it came into existence roughly 13.75 billion years ago? This is not merely a thought experiment, but the very core of cosmological studies. Let's dive into the Big Bang Theory, the leading explanation about how the universe began. According to this theory, our universe was born from an incredibly dense and hot state about 13.75 billion years ago. In a fraction of a millisecond, the universe expanded from a singularity, an entity of infinite density, into an enormous and ever-growing cosmos. In the immediate aftermath of this explosion, primordial light, the first light in the universe, began to streak across the cosmos. This light, which we now observe as the cosmic microwave background, was the herald of a universe in the making. As this light spread, the universe itself was also expanding, an expansion that has never ceased. But what exactly is driving this expansion? Enter dark energy. This mysterious and unseen force is thought to permeate all of space and increase the rate of expansion of the universe. Since the universe's birth, dark energy has been pushing galaxies apart and causing the cosmos to grow at an ever-accelerating rate. Imagine the universe as a loaf of raisin bread dough. As the dough expands or rises, the raisins move farther apart, but they aren't moving through the dough. Instead, all the space in between is expanding. That's somewhat how dark energy works on our universe. So how big is the universe now? While we can't provide an exact measure, cosmologists estimate that the oldest photons, the particles of light we can observe, have traveled a distance of 45 to 47 billion light-years since the Big Bang. This suggests that our observable universe is approximately 93 billion light-years wide. This vast expanse of cosmos contains everything we can possibly observe, from quarks to quasars, from stars to galaxies, and from nebulae to black holes. Still, it's just a fraction of the whole universe, the edge of which remains a mystery. The photons we observe have traveled a distance of 45 to 47 billion light-years since the Big Bang, making our observable universe some 93 billion light-years wide. How can the universe be 93 billion light-years across if it is only 13.8 billion years old? Such a paradox may seem perplexing, but it all comes down to the concept of special relativity and the expansion of the universe. Imagine two objects in space. According to special relativity, if these objects are close together, they cannot move faster than the speed of light with respect to one another. However, this law does not apply to objects that are extremely distant from each other, especially when the space between them is expanding. So it's not that these objects are violating the speed limit of light, but rather, the space between the objects itself is stretching, causing them to drift apart at incredible speeds. Think of it like this. You and a friend are standing on a giant rubber sheet. If the sheet starts to stretch, you and your friend will move apart, even though neither of you has actually walked away. In the same way, galaxies are not racing through space, but the fabric of space itself is expanding, causing galaxies to move away from each other. This might lead you to wonder, if everything is moving away from us, then are we at the center of the universe? Well, not exactly. No matter where you are in the universe, it will appear as though everything is moving away from you. This is because the expansion of the universe is happening everywhere at once. Now, let's circle back to the paradox we mentioned earlier. How can the universe be so vast if it's not that old? The answer lies in the very expansion we've been discussing. The most distant parts of the universe were closer to us in the past, so their light has had time to reach us, despite the universe's continuous expansion. This facet of physics is the key to understanding what lies beyond the edge of the observable universe, and whether we could ever get there. It's a captivating journey into the mysteries of the cosmos, a journey that challenges our understanding of space, time, and the very nature of the universe itself. Can we ever reach the edge of the observable universe? This question has intrigued scientists and space enthusiasts alike. The answer lies in our ability to develop unimaginably advanced modes of transport. Let's consider two theoretical methods that could, in theory, allow us to reach the edge of the observable universe. First, we would need to travel faster than light. This seems like a simple enough proposition, but according to our current understanding of physics, It's impossible. Einstein's theory of relativity posits that nothing can exceed the speed of light. This doesn't just apply to physical objects, but to information as well. So as of now, this method appears to be off the table. The second method involves transcending space-time itself. This might sound like something straight out of a science fiction novel, and you wouldn't be wrong. Concepts like wormholes and warp drives fall into this category. These hypothetical shortcuts through space-time could, theoretically, allow us to reach distant parts of the universe in a short amount of time. Yet, despite the tantalizing possibilities, most physicists consider these methods to be highly improbable, if not outright impossible. Our current understanding of the universe, its rules and its limitations, simply do not allow for such phenomena. However, the universe has a habit of surprising us. As our knowledge and technology evolve, who knows what possibilities might unfold? We've made leaps and bounds in our understanding of the cosmos over the last century, so it's not beyond the realm of possibility that we may one day find a way to travel to the very edge of the observable universe. As we ponder these possibilities, let's not forget the vastness of the universe we're dealing with. The entire universe's size is at least 10 to the power of 23 times larger than the size of the observable universe. That leaves a lot, and I mean a lot, of universe unexplored. What exactly lies beyond the observable universe? What are we missing? These are questions that have long intrigued and baffled astronomers and space enthusiasts alike. The limitations of our knowledge about what lies beyond the observable universe are largely due to our inability to see or measure it. However, this hasn't stopped scientists from proposing a host of theories about what could exist in the unknown. One such theory proposes that our universe is just one of an infinite number of universes in a multiverse. Each universe, according to this theory, could have different physical laws, making some radically different from our own. Imagine a universe where gravity repels instead of attracts. Another theory suggests that our universe is like a bubble. There may be other bubbles, other universes out there floating in an infinite cosmic ocean. Some of these bubble universes could collide or even form inside one another. The Big Bang that created our universe could just be one such collision or formation. Yet another theory, drawn from string theory, posits that our universe could be a three-dimensional brain floating in a higher dimensional space. Other brains, other universes, could be floating around in this higher dimensional space too. It's a mind-bending concept, but one that some physicists take seriously. There's also the possibility that our universe is infinite. If so, then every possible configuration of particles would repeat over and over, creating a patchwork quilt of infinite universes. You, or someone exactly like you, could be out there somewhere in this infinite expanse, living out an infinite number of lives. These theories push the boundaries of our understanding and challenge our perceptions of reality. They remind us that there is still so much to learn about the cosmos and our place in it. Despite the unknown, astronomers theorize that space outside of the observable universe might be an infinite expanse of what we see in the cosmos around us. So the next time you look up at the night sky, remember, what you're seeing is just a tiny fraction of the grand cosmic tapestry. Can the universe be infinite? What does infinity imply? An intriguing question to ponder, isn't it? Let's delve into the concept of infinity and explore its implications in the context of our universe. When we think of infinity in the realm of the cosmos, it's not just a matter of endless space stretching out into forever. No, it's far more mind-boggling than that. If the universe is indeed infinite, then beyond the limits of what we can currently observe, every possible thing exists. Yes, you heard that right, every possible thing. This doesn't mean just more of the same, more stars, more galaxies, more planets. It means every conceivable configuration of matter and energy, every variation of reality that can be, is out there somewhere. Imagine an infinite number of realities where every choice you've ever made, every chance event in the history of the universe plays out in every possible way. Now that's a lot to wrap your head around. It's like trying to imagine a number so large that there's no end to it. But that's what infinity is. It's an endless expanse of everything. It's every thought you could ever think, every dream you could ever dream, every fear you could ever fear, every joy you could ever feel. Infinity is a concept that challenges our very sense of reality. It pushes the boundaries of our understanding, forcing us to confront the idea that our observable universe, vast as it is, may just be a tiny speck within an endlessly sprawling cosmic sea. And yet, as confounding as the concept of infinity may be, it's also incredibly liberating. It opens up a universe of possibilities, quite literally. It suggests that there are no limits to what exists, to what can be. So, if the universe is indeed infinite, then beyond the observable universe, we will eventually find every possible thing. It's a concept that's as fascinating as it is perplexing, as liberating as it is daunting. But then again, isn't that the very essence of exploring the universe?